We use AI language models like GPT every day, but have you ever stopped to wonder about the very first thing they do? I mean, before an AI can write a single word of a poem or answer a question, it has to learn how to read. And the way it does that is, well, it's pretty wild. So let's just ask the big question. When you type a sentence into that little chat window, what's really going on under the hood? It's not magic, not at all. It's actually a brilliant process designed to connect our world of messy human language with the AI's world of pure numbers. And that's really the heart of the problem, isn't it? Computers don't speak English. They don't understand nuance or sarcasm. They speak math. So the fundamental challenge is, how do you take our rich, creative, kind of chaotic language and translate it into the cold, hard logic of numbers that a machine can actually understand? Well, the answer to that problem is a process called tokenization. And you can think of it like an AI's way of sounding out a word. It's this absolutely essential first step that breaks our text down into smaller, manageable pieces that we call tokens. These tokens are the bridge that lets the machine finally start making sense of what we're saying. Okay, so there are a bunch of ways to create these tokens, but one of the most clever and powerful methods, and this is the one used by models like GPT-2, is called Byte-Pair Encoding, or BPE for short. The best way to think about BPE is that the AI isn't given a dictionary to learn from. It builds its very own completely from scratch just by finding patterns in a huge amount of text. Let's make this real. We're going to walk through a tiny example. Imagine an AI is given just this small set of words. We call this a corpus, along with how often each word appears. For right now, this is its entire universe of language. It's going to learn everything it needs to know just from these 5 words. So where does it start? It starts at square one, the most basic level you can imagine. The AI takes every single word and just breaks it down into individual letters. Hug becomes H-U-G. This list of characters, that becomes its starting vocabulary. Its alphabet. And this is where it gets fun. BPE is basically a game, a merge game. The algorithm's only job is to look through all the words and find the most common pair of characters that appear next to each other, and then it sticks them together to create a brand new, slightly bigger token. All right, so your turn. Take a look at our little list of words here. Which 2 letters sitting side by side show up the most often? Don't forget to factor in the frequencies. Is it P and U? Maybe U and N? This is literally what the algorithm is doing right now. And the winner is OO followed by G. If you do the math, it shows up in hug 10 times, pug 5 times, and hugs 5 times. That's a grand total of 20 appearances. And just like that, the AI learns its very first rule. From now on, whenever you see OO next to G, merge them into a new token called UG. And right away, the AI updates how it sees the world. So the words on the screen look the same to us, but in its mind, the AI no longer sees H-U-G. It now sees the word hug as 2 separate pieces, the character H and our new token UG. The whole corpus is evolving with every single rule. And here's the thing, it doesn't stop there. It just rinses and repeats. So, looking at this new updated list, what's the most frequent pair now? The game continues. This time around, the most common pair is U followed by N. It's in pun 12 times and bun 4 times for a total of 16. So we get our second rule and our second new token, un. And again, the AI immediately applies its new knowledge. Now it sees the word pun not as 3 letters, but as 2 tokens, P and un. Same for bun. See what's happening? Instead of just a sea of individual letters, it's starting to chunk our language into pieces that have more meaning. Let's do just one more round. And look closely because now the pairs can include the new tokens we just made. So a pair could be a letter next to a token, like, say, H and UG. What do you think is the most frequent combination this time? You got it. It's the character H next to our token UG. That combination appears 15 times in total. So the algorithm merges them into a brand new token, hug. It has literally built a common word from the ground up just by spotting which pieces show up together most often. Now imagine this process, but repeated thousands and thousands of times on a massive dataset. Okay, so we've watched the AI build this tiny custom dictionary. That's cool, but how does it actually use all these rules to read a new word it's never seen before? Well, it follows a really clear 4-step process. First, it cleans up the text a bit. Then it breaks it into individual words. Then it splits those words all the way down into their basic characters. And then, and this is the key part, it applies those merge rules it learned, one by one, in the exact order it learned them, to piece that word back together using its new vocabulary of tokens. And this right here shows you everything. It shows you why this method is so clever, but also where it can fall apart. Take the word bug. It works perfectly. The AI splits it into B, U, G, sees the U and G, and applies our first merge rule. The result? 2 tokens it knows, B and U, G. But now look at mug. It fails. Why? Because the letter M was never in our original training data. It's a total unknown. The AI has no idea what to do with it. You can see how this unknown token problem could be a huge deal, right? How can an AI possibly read the entire internet if it gets stuck on a single new character or an emoji it's never seen before? Well, the big models, like GPT-2, use an incredibly elegant solution to get around this. Like we just saw with the word mug, building your whole system on a fixed set of characters is, well, it's fragile, it's brittle. A global AI can't afford to break every time it sees a new symbol. The system has to be totally foolproof. And this is where the real genius comes in. It's a trick called byte-level BP. Here's the idea. Instead of starting with an alphabet of characters, like A, B, and C, the AI starts with an alphabet of bytes. Every single thing on a computer, every letter, every number, every emoji, every invisible character is at its core just a sequence of these underlying bytes. And this is the magic number. There are only ever 256 possible values for a single byte. That's it. So by building its alphabet from these 256 fundamental units instead of a random collection of letters, the AI gets a complete, universal vocabulary right from the start. Yeah, this quote from the source material just nails it. You start with this tiny base vocabulary of only 256 pieces, but because everything is made of those pieces, the AI is guaranteed to be able to represent any character, in any language, now or in the future, without ever running into an unknown token again. It's a beautifully simple and robust solution. And all of this leaves us with a really fascinating final thought. We humans, we think in words, in ideas, in concepts. But an AI, using this method, builds its entire understanding of language from the ground up, starting with raw digital data, just bytes and statistical patterns. It never really sees a word the way we do. So you have to wonder, does that mean it's developing an understanding of language that is profoundly and maybe permanently alien to our own?